Welcome back to part 2 of lesson 12.2, solving limits algebraically. And we're going to look at example 5 here, which is using, you have a polynomial, and you want to take the limit of this polynomial as x approaches negative infinity. And when you do that, remember from the properties that you wrote down at the very beginning, I'm going to reference it, go back. It says number 15. When we're doing the polynomial, we're only taking the highest exponent and we do not play with the rest of the function. So here, I'm basically going to ignore this part of the problem and I'm only dealing with this first term because it's the highest exponent. So I am taking the limit as x approaches negative infinity of this 4x to the 6th. Okay, now think about this. If it's a negative, well, we can do the property first if you want to pull that 4 out. We can pull the 4 out of the limit as x approaches in negative infinity. But think about the exponent. That 6 is even. So if I put in a huge negative number in there for x, I'm going to have a positive number. I'm going to have that positive infinity. And that would multiply by the 4, so that would give me a positive 4 times infinity, which in fact is just infinity. Okay? 4 won't matter. But the positive value here is because that is an even exponent, even though we're going to negative infinity. All right, let's look at a rational function. These are kind of fun. When you have a rational function, you are basically going to split this up into as many different terms as you see. And the way you're going to do that is you are going to divide by the highest exponent that you have. So here I have the highest exponent is the 3, x cubed. So I'm going to divide each and every term by x cubed. So I will have 7, I'll be taking the limit as x approaches infinity of 7x cubed minus 3x squared plus 1, all divided by x cubed. That's just the numerator. Then down here, my denominator, I'm going to have 2x cubed plus 4x, and I'm going to divide them as well by x cubed. The reason is it's the highest exponent. Okay? Now we need to simplify this. When we do that, we have the limit, again, as x approaches infinity. That would go just to 7. Minus, that would be 3 over x plus 1 over x cubed. This would be 2 plus, that would be 4 over x cubed squared. Now remember from your properties as well, this one right here, if you're taking the limit 1 over x to any power, whether it's 1 or any other value, it equals 0. So these values right here, the limit of each one, remember also from your properties you can take the limit of the 7 minus the limit of this, the limit of plus that. Right? So this all, each one of those is going to go to, in fact, 0 when you take the limit. And you will be left with the limit of 7/2. Which equals, you can leave it that way or you can make it 3.5. I don't care. I prefer the 7/2 though. Okay. These are kind of fun. You know, I think I'm going to do one more example. It's a small one. Let's just write out one more example. Example 7. If you want to take the limit as x approaches infinity of negative 3x squared plus 7 divided by 5x plus 1. Here, your highest exponent is x squared. So we are going to divide every term by x squared. We've got negative 3x squared plus 7, and we're going to divide them by x squared, and that's all over 5x and 1 being divided by x squared. Okay. Now we're going to simplify this. Scoot this up a little bit. So simplify each one, and that would give us, here that gives us the limit, of -3, and this is 7 over x squared. This would be 5 over x, and that would be 1 over x squared. Okay. And then when you take, remember the limit, these go to 0, those rational functions, and you're left with -3 over 0. 0 plus 0. And you think, well, Ms. Reams, that's not possible. All right, I want you to think out of the box for a minute. I want you to imagine that you have -3, it could be any number for that matter, and you are dividing it by the numbers that are approaching infinity, that are really, 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 really tiny, and they're approaching 0. Okay, really, really, really small fractions here. When you divide by those really, really, really small fractions, you reciprocate, and that would be multiplying by the -3, and that value essentially becomes that negative infinity. That negative makes it negative infinity. If you divide by a very, very, very small number, you're really multiplying by the reciprocal, which would make it huge. So I know this concept's a little hard, but that's why I wanted to put this example in there. If you divide by the zeros, you're taking the limit, then it actually goes to, this particular one goes to negative infinity because of the -3. Okay? All right, so when you come to class, we will play more with these on our assignment. Thank you.